Again, welcome to the second day of demos, and the demo number 2 is going to be a little bit more extensive than the last part, but here we go again. Here back at again Excel with the classic. Today we are doing cross tabulations. Everybody is excited, of course, and in today's examples we are going to use two variables, which are the education level and the subjective happiness, and we are going to figure it out if these two variables are uh, associated with each other. So today we are going to learn a new trick, which is the pivot table, and the pivot tables offers a flexible option to do different kind of tables and calculations, but today we are going to use basically a cross tabulation. After you click the button designated by the previous slide, you will be greeted by this menu, and this is a pivot table menu, and you have to select first the data, which is indicated by the select table or range. So you put there your dataset, you go to the another sheet and go through the whole dataset, select everything from the ESSP sheet, because we are going, it's most practical way. You can get all the variables there at once and you can use them. No need to fuss around with single variables and stuff like this. So select everything. It's going to be easy, most non-complicated way. And then you can do the pivot table on existing worksheet, what you have already selected, or a new worksheet if you like to. The choice is yours. And now the actual pivot table has been generated. And as you can see, it creates the framework of a cross tabulation right there. And we have certain kind of menus here which we can operate. There is every variable there now available for our usage, and that's more practical than selecting just what we need. We can select everything and worry about anything later. Now let's select our independent and dependent variables, which were the educational level and happiness. So we put the educational level on rows as its independent variable, and the dependent variable we put on the columns. And for the values we dump the dependent variables also. And let's just remain it to be count of happy. So we can do the row percentages later, but we can change that from that menu also. So it will change, does the table project frequencies or does it project percentages? But let's state right here, right now, at the frequencies. So great, now we have the table here, what we can use. Note that the blank there just indicates the missing variables there, or the missing observations, sorry, and we can ignore that line. We are not interested about how many missings there are. We are interested about the actual information on the table. So ignore the blank line or just color the numbers in white if you don't want to see them. And now we have to copy paste the number information under the table, because we have to calculate expected observations for the CJ square test, because we have to find out if these are statistically relevant, the like the what, how do you say it, the relationship between education and happiness. And here the pro tip is also, when you're pasting the numbers from the pivot table, just use the pasta special in a way that just paste the numbers there. You don't want all that pivot table format crap. I don't remember, it probably pastes all the information correctly, but that way you just get the raw numbers, and it's also easier that way in a way. And now we have the observed count here, or the observed frequencies, and now we need to count the uh, what are the expected frequencies, and we get that by using edge frequencies and total observation, which are marked here. And the equation is following what you see on the screen, but here is the note: the dollar marks will lock certain kind of action from the cell, because we wanna just drag the formula over the other cells to automate the calculation process. But then the whole basically whole the calculation moves in the rows with it. So if we select these edge rows and the total observations, they are going to move to empty cells, and we don't want that. So we use dollar signs, for example, in front of a number, then the rows are locked. It only stays on the designated row. And if the dollar sign is front of the letter, it means it only stays on a certain column. So as we play around, we just want to use rows or columns, we can lock them in. And of course the last one with the observations, we just want it to stay on the one cell. So we put dollar signs on the front of the letter and front of the number. So we are going to lock it in place, and we can calculate every single cell like this without doing extra calculations at all. It's totally automated that way. So now we have the expected frequencies here. So we have to put it in a column form. So let's put the observed frequencies and expected frequencies nicely together here, like this, in one column each. So we are going to then utilize the chi-square test and obtain the p-value, and it calculates the p-value straightly. It doesn't give the chi-square test number, it gives the p-value straight on, so we don't have to use the table like last time. But you are going to fill the array. There's array 1 and 2, what the chi-square test wants. The array 1 is the column for the observed frequencies, and the second one is for the expected frequencies. You just drag over those numbers what it requires, and you're going to obtain the p-value, which is statistically really significant. Thus there is an association between the education level and happiness. And you can also calculate the degrees of freedom, which is part of the chi-square calculation, by doing following formula provided here. And finally, if you want to see the row percentages, you just click inside the pivot table with the right mouse button, and you're going to get the menu. You press the show values and the row totals. So it will automatically transfer all the numbers to row totals. So pretty easy, right? That's way you can construct a more prettier table for your publications. And here is the final product. Of course, we are not going to publish any crap, so here is the cleanup table, or the one variation of it. You can mix it up, do whatever you want, but the clean table is always clean table. And for sake of simplicity, there is no chi-square number on the left corner. We could calculate that by hand, but let's not do that. Let's just put it right on with this, but normally that would be also included on the table. Better statistical programs provide this information straight on, and let's just not do it. It's not worth of the hassle. Let's just go with this. Do the task 1 now. And we are right back. Here it's the same business like last time. We need a pivot table and select the whole data basically. And we are going to put rows and columns there, area for rows and religious activity for columns. And the central idea, or what I played in my head, that the more rural areas could be more religious than the large cities. This is old research founding, and I tried that. Why the hell not? Let's just try it. And let's of course copy the values from the pivot table under the table, or use straight the pivot table numbers for the expected frequencies. So this is pretty straightforward. You have to just replicate what I had done, and that's that. And remember to use the dollar signs to automate calculation, and everything is smooth sailing. There is no problem in anything, and you don't have to do any extra work. And always remember, laziness is the best thing the professional to have. That's the road to be an efficient researcher. Just like the last time, construct a custom table for expected and observed frequencies, and there use the Z-square test for calculate the results. And in similar fashions, degrees of freedom by utilizing the same formula what we had in the previous lectures, or you just copy what I did in the Excel file if you don't want to go back all the way and find the place in the slides. So it's not that simple. What did I say? It's not that simple. No, this is really simple actually. Everything is automated. You have to do a little bit tapping. Of course, nowadays every statistical program does everything for you, but now you know how to pull up these numbers and do something like that. And you don't have to do it ever again if you don't like to, because you have the information and freedom to do whatever you want in any possible way. And here are the results. And this is the cleaned table version, of course, for the publication style or something like that. And as a result, so there is a statistically significant association where rural areas, the people who live in rural areas, visit religious services more often, but only in annual time period. And in addition, in large cities, there are majority of those who do not visit religious services at all. And there is also a extra color-coded version, so you can see the differences a little bit better. And at this point, for a joke, I have to say that if you're wondering why my throat is sounding dry or something like that, it's because I have recorded all these lectures on one go. So my voice is trying to say no more and it's shot to shit, but I'm going to power this on, and we are going to see next time in correlations and linear regression demos. That's the last one what I'm going to record. Hopefully I'm going to survive that, and hopefully you are going to survive that. Of course you are smart people and you are going to win this thing. So see you there, see the lectures beforehand, and let's go to the best method ever created for social scientists, which is the linear regression, the basic tool what everyone uses. See you there. Bye bye.